right, folks, we are working on the closure problems, and with that we're starting at 8-156. So with all of this, we're looking sort of more in depth with limits, as we've been doing with the whole chapter. Certain things that aren't really going to be covered too much is things like proof by induction, or sort of the idea of like analyzing, say, something like the Fibonacci sequence. It's mostly going to be simpler than the last three sections that we've done, but it is going to contain everything before those last three sections. So with this, we're working on 156 to 164. And so with it, we're going to be doing some stuff with limits, such as manipulating functions to find where their limit is at infinity, critical points, and various other things. So if we go ahead and we have our function right here of f of x equals x squared minus 3x minus 4 all over 2x times x minus 4. Now, one of the key things we want to do is we're going to be finding limits of this function. So what I would suggest doing is that we break up the top of this function into its components and sort of factorize it. So when we do that, we get f of x equals, and then for this one, if we do the diamond, we have -3, -4, which means one of these is negative. If we think about it, we have -4 and 1. So we have x minus 4 times x plus 1. All over 2x times x minus 4. Now, for A, we have our we have the limit as x approaches infinity of f of x. Now, when we look at this, since we're looking as x approaches infinity, all we care about is our x terms, and we don't care about, or like our leading terms. If we wanted to, we could sort of undo the process and sort of get back to an x squared and what would be here for our leading term, which would be, if you take a moment to think about it, would be 2x squared. So we have, if we write it out, f of x equals x squared minus 3x minus 4 over 2x squared minus 8x. And since this is an issue where we're looking as x goes to infinity, if we remember about sort of growth terms, we have these two terms, which are our leading terms, are the only ones that are going to matter. And since they're both at the same power, they're both x squared terms, we're just going to look at the ratio of the coefficients. So we have, if we look at it, we end up with something that's approximately x squared over 2x squared, which when we cancel out the x squareds, we have 1/2. And so that'll be our limit as x approaches infinity. Now, if we move on down, give ourselves some more space, and now we do B. So now we're looking at our function as f of x approaches 0. Well, let me clear this up because I wrote it poorly. So lim as x approaches 0 of f of x equals if we look at it in our function over here, we have x squared and we have 2x. So when we plug 0 into the top, we're left with a -4. However, when we plug it into the bottom, we're left with a 0, which sort of gives us, lets us know that there is a vertical asymptote there. Now, if we look at this function, to the left of it, we're going to just sort of plug in a value and just sort of see what our function's looks like. So if we go to the left of it, say -1, then we still have a negative number in the top and we have a positive number in the bottom. If we go over to, say, 0.5, then we end up with still a negative on the top, but then a negative on the bottom, meaning that it sort of has it goes kind of like this at x equals 0, and therefore it has no limit. So that would be undefined / no limit. And then we are going to move on to C, which would be limit as x approaches 1 of f of x. Now, if we looked at sort of our values, if I scroll back up briefly, we have a 1 right here. So if we look at x approaches 1, then what we have is, if we plug it into our thing, plug it in, we have 1 squared minus 3 minus 4, so it would be -6 over, and then we plug it into the bottom, so 2 times 1 minus 3 is -6. So we end up having limit as f of x as x approaches 1 would be 1. And so then we'll just box these answers, and then we'll move on to D. So D is where it gets tricky. Now, up here, we have our function sort of factored out. So what we could do is we could say it's approximately equal to x plus 1 over 2x. Now, for f of x, it's not actually equal to this, because if we were to graph f of x, there would be a hole at x equals 4. However, since we're finding the limit, we can approach a function which sort of ends up having a value at there, which would be this function. So, if we then sort of write that out, so lim as x approaches 4 of f of x is going to be equal to the lim as x approaches 4 of x plus 1 over 2x, which when we plug in 4, we get 4 plus 1 over 2 times 4, which equals 5 over 8. Now, that is what we get for D. So, with this, we just went through 8-156, and I will sort of stop this video here and sort of record one for 1-57.